All right, so this implicit differentiation comes in really handy when we start talking about light changing as it enters through a lens. So when we talk about a light entering a lens, it goes perpendicular to the surface or normal to the surface. So especially with ellipses, this is the general form of an ellipse. It looks pretty nasty, but the easiest way to do the derivatives or slopes of these is with that implicit differentiation. It's impossible to solve this thing for y and do it with a normal derivative. So we have to use implicit differentiation. Now notice example 4 asks us to find the tangent and the normal. So I'm looking for two equations here. In order to write an equation, we need to know a point and a slope. So when we talk about this particular problem, I have to do the derivative, and then we're going to talk about the perpendicular as well. So let's start with the derivative here. With respect to x, derivative of x squared is 2x. Now I'm going to leave this one alone for just a minute. Over here, derivative of y squared, I'm going to go ahead and leave some space, is 2y dy dx with respect to x. And then the derivative of 7 is 0. Now, what I hope you notice is right here we've got this minus x times y. I want you to circle that and write yourself a note. We have to do product rule here. Now, I'm going to do the minus out front, and then I'm going to do the product rule inside. This way I remember I have to distribute this negative at the end. So product rule says to do the first times the derivative of the second. So the derivative of y with respect to x is 1 dy dx. So I'm just going to put in the dy dx. So first times derivative of the second plus the second, which was y, times the derivative of the first. And derivative of x is just 1. So notice this one does not have a dy dx attached to it because the derivative here was already with respect to x. This was not a derivative. So now when we write this out and distribute that negative, we get minus x dy dx minus y. I have to distribute that negative plus 2y dy dx equals 0. I only want my dy dx terms on this side, so I'm going to take this 2x and this negative y and move them over. So I'm left with negative x dy dx plus 2y dy dx equals negative 2x plus y. Next step said to factor. So I'm going to pull the dy dx out, and I'm left with negative x plus 2y. And then solve. So divide by negative x plus 2y. Now, I want to point out, if you had done this the other way and you had moved the dy dx terms to the right and then done all the division, your answer would be exactly opposite of what I have. Like this is a positive, this would be a negative, this would be a positive, this would be a negative. That is an equivalent answer and it's totally correct. So please note that if your answer is ever exactly opposite of what I have in my notes or in my homework, it's exactly correct. Now, what we just found was the slope, and they want us to find the slope at negative 1, 2. So that means for all my x's, I'm going to plug in negative 1. For all my y's, I'm going to plug in 2. So when we do that, we get a slope of 4/5. So now I've got a slope, I've got a point. So the equation of my tangent line is y minus 2 equals 4/5 x plus 1. And then my normal line, exact same equation. but opposite reciprocal slope. All right, I want you to try this one. I want you to do the first derivative, and then I'll check in, and then we're going to do the second derivative. All right, so here's what I got. I've now got the first derivative. So they're asking us here in this notation to find the second derivative. So that just means we do the derivative again. So what rule do I have to use to find the second derivative? This one is a quotient rule. So now I want you to do the quotient rule and see what happens. So I did low d high less high d low over the denominator squared we go. So notice that this second derivative has x's, y's, and a dy dx. Here's the cool thing. We know what dy dx is. It's right here. So I need to replace dy dx with x squared over y. So I get this new equation, 2xy minus, I've got x squared times x squared, which is x to the fourth, over y, all over y squared. Now I have a little bit of an issue. I don't want to have a fraction on the top. So in order to get rid of this divided by y up on top, the easiest thing to do is multiply the entire top by y. But if I do that, I also have to multiply the bottom by y. So my final answer ends up being 2x y squared minus x to the fourth all over y cubed. Now I want you to notice there's not an x in every single term. There's not a y in every single term. So there's nothing that will cancel out. That's as far as I can go. This is the second derivative. It's yummy. All right.